Esta charla creo que la vamos a hacer en inglés, porque bueno.
Sí, hay algunas personas en el stream en inglés, entonces digamos, half Spanish, half English. Questions can be in Spanish or English in the end. It's no problem. So I'm going to talk a little bit about our latest migration. We've been doing a bunch, so that's actually why this first slide is important. We when we decided, and I'll go into detail as to why to migrate from one cloud provider to another, we were already migrating millions of users from the Easy Taxi platform to the Cabify platform. So we couldn't use the migration name, and we decided to call this an exodus from our current cloud provider. So that's sort of the background on the name, because it appears in some of the documents. So I think it's worth mentioning. Also, a disclaimer, I just got off a plane and I've been traveling for like 30 hours. So if I make a mistake, there's some people from Cabify that can maybe help me here. So, oh, well, that's not exactly what we did, but it should be mostly accurate. So some background as to why we were on our current cloud provider. And the main database powering Cabify is one that you might not know about. It's called CouchDB. With the strike through and relax was added by me. It's not actually on the original logo, but it's how we. To why we were there, then as to why we decided to move. Let's see. Okay, so this is our internal metric on. This is the blue one is the number of drop-offs, which is probably our most important metric now, is when a trip is completed. Then on the yellow one and the purple one is requests and trips that are being picked up. So at the end of the day, these are the three key metrics for Cabify. We have the current value, or the actual value, and the value from last week. So it helps us kind of see what the trend is. And what you're seeing here is a very major outage that lasted around 13 hours. So this was mainly the motivation for changing. I think we could do a whole talk on what happened in these 13 hours and how we actually managed to not be at zero on drop-offs, because this was a crazy team effort of people trying to rescue the systems, rescue the servers. As a quick detour, what happened is that one of the routers or load balancers, I remember in the data center, went down, and the backup one didn't pick up the traffic. So in one of our main data centers, we were not able to access our systems. Our services could not talk to each other. So it was a major catastrophe. And in our internal sort of like risk analysis matrix, we always thought, we're not maybe in the best cloud provider in the world, but if there's a 1 hour outage, it's something that we can live with. We have precautions in the system for that, but it was never in our risk matrix. What happens if this goes down for over 10 hours, for over 12 hours? So the day after this happened, or actually during the call, one of the corrective actions, because we write postmortems and we have a really cool continuous improvement sort of like architecture for when things go bad. It's completely blameless. We blame the processes and how we do things. And the main corrective action for this, we discovered obviously things that were our fault, and it's not all on the cloud provider. But one of the corrective actions that we listed was we need to move into a top tier cloud provider as soon as possible. And we literally started drafting a plan, in fact, because we thought this might go on even longer. And being down for over 12 hours would be like catastrophic for the business, for our users, for our investors. We actually started to discuss how could we migrate to another cloud provider live during the call in a few hours. So that's sort of how this started. Once the system recovered and once the data center was sort of like more stable, we said, okay, let's do this as soon as possible, but not literally like in a few hours. Let's plan this and let's think about how we can actually make this work without disrupting the system. Because we did come up with a plan, and we actually started spinning up machines and creating projects and creating networks. But there was a high risk of, okay, if we move things after not sleeping for 13 hours with everyone tired, what if we make a mistake and we bring everything down in 2 different cloud providers, and then we end up with data in both places, and it could turn into like a week-long outage. So we said, okay, things are working for now. Let's plan with a little more calm. And so we decided to create a document where everyone could put ideas, where everyone could put up problems. This is the photo of the exodus, of everyone carrying their stuff and moving into another provider. This is the actual document. I took a screenshot of how it happened because I think it's important the scope of how we decided to approach this, and the approach was pretty simple. We said let's move things to GCP, Google Cloud Platform, exactly as they are. No improvements, no changes, because obviously we are all engineers, right? So you say, okay, we're going to move. Well, we could use this other new virtual machine or this version of whatever system and component. And I was like, yes, we need to continuously improve the system, but for this specific task, what we want to do is complete our goal of let's move to another provider and let's not disrupt the service or disrupt it as little as possible. So we decided, even if we find something that we want to change, let's note it down and we'll attack it in the future. So this document is, by the way, can everyone hear me okay? I forgot to ask. Yeah? Cool. So the document is about 30 pages long of just single line ideas or tasks to be completed or potential problems. We would tag people in comments. This is all Google Docs. It was our official migration coordination tool. So it was like, oh, I just thought about this possible problem. I'll tag this person who knows how to do it. They will get a notification. They jump into the document. We also created a Slack channel that I'll share some screenshots of in a second. But I would say the most critical or thing that I think worked the best is that we had a massive checklist inside the document. Like I said, it's almost a 30-page long checklist where we went through, before executing, obviously, what do we need to do? What's the step-by-step? And let's review it multiple times to say, okay, if we executed this today and we did these steps, what would happen? And we say, oh, we forgot this, or here, if we change this IP address, well, we have external customers that are banks and they're used to fixed IPs, so we need to actually let them know before we switch. And we started sort of like to uncover and discover, like Cabify is such a large system now that there's no single person that knows everything, right? So this document was a way of, okay, let's combine all our brains, let's try to list one by one the concrete steps that we have to take to execute the mission, and to share some of the maybe more complicated things that appeared on the issue list. We had this of external customers connecting to a fixed IP, so that one was easy to fix. Let's create a new IP. Let's let them know the approximate date where we're going to change and get them to change. But how do you deal with state? How do you deal with, because this is important, we decided to do the migration without having any downtime, which meant we need to have 2 active data centers at the same time. And for stateless things, I'll say that's relatively simple. But in Cabify, what happens if your driver is pointing to one data center, but your journey is being processed in another data center? We can't have duplicate state. So as much as we try to make things stateless, at the end of the day, our business has states, right? A journey goes through a state machine. The driver is on the way to pick you up. You're traveling. We're charging. I mean, there's state in there. No? So it was a real challenge. How we're going to do this? It helped that we did not switch our database. No? So the context I shared of, well, we went to SoftLayer because our database was there. We decided to leave the database there. We ran some latency tests, and it was like, okay, we can be in GCP, and the latency will not be crazy. So the database was taken care of, but it's not the only data storage that we have. No, we also have cloud SQLs. We have caches with mostly Redis. So what happens with those? As many of you might know, like Redis is not designed to be used across the internet. There's no security, so it's secured by being in the same network. So the team came up with really clever ways of, okay, how do we make tunnels where we can encrypt our traffic and actually physically connect to, well, not physically, literally physically, but connect to data centers so they can actually share a Redis instance while we are switching. We knew this was temporary, so it didn't have to be absolutely rock solid. But if it failed, the migration would be impossible. No? The exodus would be impossible. So we ran a lot of load testing. It was probably one of the trickier components that we had to build. No? How do we sync the state? Then another cool challenge was we use NSQ queues for a bunch of message passing additionally to PubSub. And that also carries state, no, in a sense, and it determines who's working on what. So we needed to sync that across data centers as well, and we actually built an NSQ synchronizer on top of PubSub that sort of like implemented the synchronization without having to adjust any of the clients. So we could just deploy services in two different data centers. They could connect to what they already knew, and magically, with a lot of work from the team, things would work. We decided to do this slowly. So that was another challenge because we have caches that need to be warmed up. So if we just said, okay, at this time, we're going to switch 100% of the traffic, not all the caches were shared, so they need to warm up. They would attack the database, and we would probably bring the whole platform down. Now, this has happened before where the caching system starts to fail, and we can request so much from the database that it can't take it. No? So we had to come up with a very clever way of migrating traffic progressively, because as I said, there are like certain components that have to live together. It's not like, I'll deploy this container here and this other container here. There is state that has to be shared. So the solution that the team came up with was very cool. Is we use DNS records to migrate country by country where the different client applications were pointing. So we could say, okay, if you're accessing our DNS record from Spain, you're going to go to SoftLayer. But if you access it from Colombia, you're going to go to GCP. And that allowed us to sort of have some control over what the traffic migration would be. We could reverse it. So we could say, okay, this is not working. Let's roll back. And this is sort of how it looked like when we passed the yellow one is a traffic on SoftLayer. The green one is a traffic on GCP. And you can see the time where we passed 50% of the traffic being on each, and then more and more traffic being on GCP. It worked really well, and we had another really cool achievement, I would say, from the team is how do we track the progress? And because all our systems are sort of like declarative, we have a manifest where you say, this is my service, this is what it does, this is where it's running. We could automatically create lists of, okay, our tier 1 jobs or services, how many of them are migrated? And this was automatic, right? There was no human sort of like updating these lists. It was when you deploy it, once it's working, it's declared as being on both data centers, and this temporary Grafana dashboard would pick it up and sort of like let us know what the percentage of the migration was. We ended up with discovering more services than we thought existed. So that's why we actually migrated over 100% on some of the metrics. And here's also a good moment to describe a little bit of the Cabify architecture, which is divided into tiers. So the tier 1 is sort of like the most critical. Well, we actually have a tier 0, which is kind of like the infrastructure, the monitoring, the metrics. But tier 1 is what you need to complete a ride. The services that are required so that when you request something, a car can actually pick you up, a car can drop you off, you can get the address of where you're going. So that's what we call tier 1. And an interesting one here is that charging credit cards is actually not on the tier 1, which is like critical to the business. But because it's something that we can do later, we can actually operate the platform without charging credit cards. Once the tier 2 is recovered, we'll start charging. Obviously, it's not plain because if the tier 2 were to be down for 6 hours, well, you're going to get a charge on your credit card 6 hours after your ride. So like, the experience is not ideal for passengers. But at the end of the day, we want to be confident that the tier 1 will always work. So you'll always be able to go from A to B because that's the value proposition that we offer our customers. After that, we'll charge. And tier 3 is sort of more analytics, data processing, reporting, and how we use information to make better decisions. So if that's offline for a whole day, I mean, we're going to have one whole day of sort of bad decision making or not up-to-date information. But people are going to be traveling, we're going to be generating invoices, we're going to be charging credit cards. So just a quick side tour on why we divided that into tiers. Then another interesting decision from the team on, okay, let's say we already have everything deployed. We have the tunnels, we have the NSQ automatic translation with PubSub, and how are we gonna test this? And I cut the picture. We actually have the author of the Slack message here. Okay, we have everything. How do we test this? Before actually moving traffic with the DNS records for actual customers. And the idea there was, well, why don't we create a new country or a new city, a new region, and actually do live testing there. We create drivers, we simulate their movement, and this is a lot of work done already by the QA team, which is what they use to test the applications. Some testing is manual, but they can simulate routing and locations and drivers moving, picking up passengers, dropping off passengers. So we said, okay, let's create a new country, let's create a new city. It has to be a country where we are not operating, where we don't have people operating, where we don't think we have a lot of customers because we did switch the DNS records. So if someone has a DNS record for Nairobi, they would actually be pointing to the new data center, and it's funny because it actually happened. We tested this. Then I think we tested with Poland, where we're not operating either. But it turns out if you are from Poland and you're traveling in Spain, your DNS on your phone is your carrier, which is in Poland, and it will actually give you the IP address of the new data center. So we started to see traffic even before we thought it was possible. But everything was working, so it was good news. We tested ourselves in Nairobi, charging credit cards. Then we released our first country, and we actually started to see traffic, organic traffic from users, and we started to verify that things were working. We decided to do sort of a control migration. We looked at the same graph that I shared in the beginning. So as you can see, without looking at the downtime, our traffic is very seasonal. We have peak periods, valley periods. So we decided to coordinate on schedules and say, okay, so 6 a.m. in Madrid is a good time to migrate traffic in this country because in that country is like 1 in the morning or midnight. So there's not that much traffic in the middle of the week. And we identified what were the proper times for each one of the countries to migrate. We would wake up early in Madrid or in wherever the team. We have a lot of remote teams, so this was happening across multiple time zones, and we had people alert at all times. but it worked really well. We migrated country by country, and this graph that I was sharing, is showing sort of like how smooth the transition was. It's what we ideally wanted to see. We would have been able to reverse things if they were not working. It was not necessary. I think another interesting detail on sort of like learnings, So this is we found a lot of skeletons in the closet. This is the thing. A lot of things that maybe we thought about it a few years ago, but no one thought about it again. Maybe things that no one knew about. So what we did was we kept a list. We stayed true to almost 100% the exact same thing we have on our existing provider. Let's move it to the new one, and it worked really well. And now we're tackling the different sort of pending tasks that we identified. So this was a humongous team effort. I'm the one telling you the story, but my responsibility in this was looking at the plan, getting it approved by sort of like the senior leadership of the company, right? Because it was a big risk. I think I did contribute some ideas, but this was a 100% the team. Our infrastructure team, ambassadors from every single team in the company. This is a really cool team effort. We actually the expectation, because I consulted this with people who've done it in the past, is that it would take around 19 weeks for a normal company to switch from one cloud provider to a new one. We were able to do it in 3 weeks, and we're seeing incredible results in Google Cloud. Let's not forget that while we were doing all this, we were migrating millions of users from a company that we acquired. So it was happening at the same time. The double trouble. What could go wrong? Nothing went wrong. The checklist worked. Combining the brains of so many different people into a document worked. Slack channels, coordination, calls. It was very successful, and I actually want to take the opportunity to congratulate the team again, because it was an amazing effort. We are now actually we have doubled approximately the volume that we transact on the platform, and because of this migration and other efforts by the infrastructure team, we're actually paying less than we were paying before, with twice the volume. So we not only achieved a new platform in 3 weeks, paying less, being more efficient with more performant machines. So it was an incredible win-win for everyone except for our previous cloud provider. And that's it. Now I wanted to leave it open for questions, whatever you're interested in. Like I said, you can ask in Spanish as well, so no problem there, and I can translate the question, or I can answer in Spanish as well. Yeah.
Congratulations. How many people
To the team, yeah.
How many people do you have in the team, and what do they do now? What are the new projects after the 3 weeks migrating? Now everything is working and they're on holiday, or what are the new challenges you are?
Perfect. So the team overall is closing to 300 people. But that's across sort of like technology, engineering, design, product management. The actual infrastructure team that was 100% dedicated to this was maybe less than 10 people, right? So it was a small team that executed most of these tasks. At the end of the day, the whole team was involved, because we needed sort of like ambassadors from every team to make sure everything was working. We needed QA to test things were working properly. So it was a whole team effort. After the 3 weeks, there was a lot of holidays. That's true, because it was an intense 3 weeks. I wouldn't say it was 3 weeks of 9 to 5, and then I go home, and so it was 3 weeks of very intense work. Because at the end of the day, we all feel very responsible for our users. We have drivers who are like the livelihood of their families depends on if they can complete rides. So if they can't complete rides, maybe it's gonna sound crazy, but their kids go hungry. It's a very very big responsibility that we take very seriously, and we knew that after we saw a 13-hour outage was possible, which again was not sort of like in our risk analysis matrix. Like if you asked me if that was possible from a respectable cloud provider, I would have said it's never going to happen. No? Once we knew that was a possibility, it was sort of like always in the back of our minds of, okay, at any time this could happen again. So let's try to move quickly. Let's try to do it right, but quickly. That's sort of the reason why we completed this in 3 weeks. Now, migrating to another cloud provider, I think another valid context is that it wasn't the first time we thought about it. So this was sort of like an ongoing thing, but it became critical when we thought the livelihood of our drivers could be affected by it. New projects, yeah. So lots of new projects. No, the team is actually working on optimizing. So now that we migrated to GCP, we actually discovered that their machines are more performant. So we're over provisioned on many services. So slowly the team is cutting where we are over provisioned. So that's an ongoing effort that's very interesting. And at the end of the day, we not only work on the infrastructure, right? So the rest of the team is constantly working on new features, on hot hire is a really cool one that we're working on, where you can our drivers will get a ride while they're completing a ride. No? So there's a bunch of cool things that are happening. If you want to know more, we're hiring. Yeah.
Here. Hi. Thanks a lot for your speech. I have a question about the DNS provider that did you use before the migration. It was Google Cloud, was another provider, or By9?
So the DNS provider that we used to be able to switch based on countries and whatnot, it was actually Amazon. Yeah. I think you can also do it on the GCP global load balancer, but I mean we need, like, the team knew how to do it on AWS, so we did that. We're pretty cloud agnostic, so wherever the best tool is, we'll use it.
For root, I assume that you use Kubernetes on Cabify or not?
Not yet. I would say not yet. So that's another big project that the team is working on.
Okay, and to balance all the service, what service do you use? Do you use Traffic or do you use your native service?
So we're migrating a lot of services to Traffic. I don't know how do you pronounce it. We have most of it on HA proxy now. Yeah.
Okay, that's all. Thanks a lot.
Perfect. And we use Nomad instead of Kubernetes. I mean, it's not like a one-to-one thing, but it's a container orchestrator at the end of the day. But we're migrating to Kubernetes.
You said at the start that Cabify is based on CouchDB database as its main database. I have read not very good things about CouchDB, about taking a lot of time to start, a lot of memory. If Cabify started today, would be your choice to use CouchDB?
So I think the correct answer was that at the time it was like a very valid competitor, for example, to Mongo. So it's a NoSQL DB. So it's like hard to know which one was going to be the winner, because at the end of the day, sort of the problem, or for at least from my perspective, the main problem with CouchDB, apart from like the start times and whatnot, because once you get used to it and you learn how to use it, I think it works very well. But there aren't any cloud providers that support it, right? So like the ecosystem didn't pan out; it's not there. So for those reasons, I wouldn't pick it today. But I don't think it was necessarily a bad choice at the time, right? And it's hard for any database or any database schema to extend through like exponential growth. So Cabify went through exponential growth. So I think no matter what the original choice was, the data model wasn't going to scale. And at the end of the day, if you plan so well that it's going to scale to 100x, that's stuff that you're not doing to improve the business to actually get to 100x. So I'm comfortable with knowing that many of the decisions that we make, even the ones that we're making now, maybe in 5 years we're going to look back and say like, oh my God, why did we do that? But it's the correct choice at the time. At the end of the day, our mission is to add value to our users, not to try out cool new technologies. Yeah. So a long answer, but we wouldn't pick it again. But I think it was the right choice. Or it was hard to know if Mongo or CouchDB was going to be the winner.
Thank you. You basically related to QA. So basically, can you give us a hint about the tools you use for QA and also for stress test and everything? Do you rely on QA or do you use it along with a SRE team or a DevOps team or platform team or whatever you want to call it?
Yeah. So stress testing the Cabify system is actually complicated because there's a lot of different components that have to interact. So you can stress test one of the components, just throwing traffic at it, but it's not the actual real kind of traffic that you're going to see from the world, right? It's when people order, if they get desperate, they cancel. Also, it's very hard to simulate the kind of traffic that we get. But the QA team, although I'll first answer the tooling sort of question. So one of the in terms of like CI and running tests, we actually run everything on GitLab. We used to be on Travis, and we switched to GitLab because our code is also on GitLab, and a bunch of our team comes from GitLab, so that might be related as well. But it works really well, and the teams are happy, so there's no issue there. In terms of how do you stress test the system, what kind of tools can you actually use to automate the test? The QA team, whose lead is here, actually. You want to explain it, or I'll explain it? Okay, cool. So you'll get to hear it from the source. And, yeah.
Thanks. Gracias. A ver, aquí dos cosas. Primero, cuando nos enfrentamos a esto, el problema que teníamos no era tanto la carga, sino enfocar bien el tiro. El problema que teníamos era que hacer pruebas en entornos previos era complicado y queríamos producción. Entonces, estábamos todavía haciendo herramientas justamente para la solución.
¿Tú pusiste la cámara? Está muy bien. Sí, ya no necesita la presentación.
En la realidad no queremos usar las típicas herramientas de los testing porque no nos sirven para lo que nosotros queremos. En el caso concreto, lo que hicimos fue centrarnos mucho en lo que el usuario necesitaba, en hacer viajes y en hacerlo de tal manera que tuviera sentido. Como datos, preparamos igual que producción y con una herramienta interna que tenemos, que llamamos InCity, simulamos el tráfico nacional. Simulamos el tráfico durante un par de horas, fue algo así, con todos los pasajeros dando vueltas, simulando el tráfico con nuestra producción de hecho. Y cuando miramos métricas todo va bien, pues vamos hacia adelante. En el futuro, pues lo que queremos es que hacemos lo mismo. Es decir, en el fondo, el load testing nos importa bastante. En la realidad hemos tenido tradicionalmente picos de carga brutales, que nos han afectado mucho, pero también nos afectan en otros niveles. Por ejemplo, el tema de la algoritmia, de cómo macheamos, de cómo funcionamos en ciertos momentos, pues estamos trabajando en ello. El approach, las herramientas son internas, en la realidad, lo estamos haciendo bastante ad hoc, y la idea de todo esto es no probar al fondo, sino empezar a simular. Nuestro objetivo en el final de este año, no. Mi idea del año que viene probablemente sea tener entornos, no sabemos en producción o poco aparte, que sean 24/7 ciudadanos. Siguiendo el ejemplo del Mercadona, pues como si tuviéramos una forma para nosotros propios para hacer pruebas.
Creo que puede ser interesante cómo funciona, ¿no? Porque siendo ingeniería, hablar de pues, el modelo probabilístico y cómo simulamos agentes, ¿no? Porque al final, como te decía, es difícil que simulando tráfico como tal simules cómo va a ser la realidad, ¿no? Porque no es que alguien ataca un servicio y luego otro, es, pues hubo esta cantidad de viajes y la gente se desesperó y llovió, entonces como...
A ver, ahora mismo tenemos la forma más sencilla posible, que es pasando en nuestras ciudades, nos pasamos por todo Madrid, vemos cuáles son los viajes más comunes. Casi siempre los viajes más comunes normalmente son por zonas, el aeropuerto, el centro a una vía, a una Atocha o lo que sea. En función de estos datos, pues sacamos data de data, que era un modelo. Los modelos son muy sencillitos, son bastante aleatorios en muchos casos, pero nos sirve para simular tráfico y simular picos de carga en momentos determinados en sitios determinados. La idea de todo esto en el fondo es saber cómo funciona la ciudad y en vez de probar, cambiar un poco el approach, porque nosotros creemos que probar como tal tiene poco sentido hoy día y tiene mucho más sentido simular. Y si fuera por mí, probamos en producción. No podemos hacerlo, pues esperamos y nos inventamos en producción. Y la idea es que cualquiera puede usarlo. La gran cosa que tenemos este año es tener eso para cualquier persona que quiera usar. Así que cualquiera que quiera usar pueda tener su ordenador, nosotros no testing
en la ciudad.
En datos y todo eso. Pero el año que viene tenemos una cosa mucho de inteligencia artificial, pero todavía no queda.
Perfect. Any more questions? Or once you saw the pizza, no more questions, right? Just remember, if this sounds interesting, we're hiring.